So the dynamic model can then be extended by including independent variables as well. In our case, it would be the business cycle, and that is X. And we include then 3 types of models. So the autoregressive model, the one where we only include a lagged business cycle component, and the one where we include both an autoregressive and a lagged business cycle. So this is basically our data. It's tourist arrivals. It's on a quarterly basis from 1993 to 2020. And we deseasonalized it using X12 procedure, and we took natural logs. So the real GDP of origin countries was then sourced from the IFS. Again, we took natural logs, and our breakpoint augmented Fuller unit test shows that it's mainly stationary, with some breaks, but where there was non-stationary, we would take first differences. So these are our specifications, just to show you that DR1 would then be the most expanded dynamic model. DR2 would just be the one with a lagged business cycle, and this would be the autoregressive model. Our benchmark models are the ARIMA and the autoregressive distributed lag model, and those were the optimal specifications that we used for them. So we have done rolling forecasts on a 1, 4, 8, and 12 period forecasting horizon. And we used a fixed window of 1/3 of our sample size, and we've only used the MAPE to calculate the best models. So just basically the first model. So this would be the results of just the basic Markov switching. And what it shows is that there's really two regimes identified, a high growth regime and a low growth regime for all the times here. So there is a cycle present in our data. And you can notice here with the transition probabilities that the regimes are quite persistent. So they keep on for a long time. So regime 2 is basically the high growth regime, except for the US, where regime 1 is the high growth regime. And the higher growth regime always keeps on longer than the low growth regime. So it's more persistent. But if you look at the volatility shift parameter, that one is always negative, and it's always significant as well, which means that volatility is also driving the ups and downs in our tourism cycle, and it has a negative impact on the tourism cycle. So I'm also just showing the most expanded model. So this is the one with the autoregressive component, in other words, lag dependent variable, as well as the lag business cycle. And so a couple of observations quickly. You'll notice, again, let me just show the high growth and low growth regimes. So the high growth states is state 1 for Netherlands and the US, and state 2 for all the others. And again, from our constant transition probabilities, we can see that the high growth state is much more persistent than the low growth state. And the only one where the low growth state is also a bit more persistent is the UK. If we look at the autoregressive component, we see that's always significant, okay, except in one case. So for both regimes, it's quite significant, and there's some persistence that is happening in tourism cycles. If we look at the business cycle one, we can see they are not always significant. So for example, for Netherlands and the UK, the business cycle is not a predictor of the tourism cycle, but for the US, France, and Germany, it is. Okay. Wrap it up. Yeah, I'm just showing the forecasting results, and then I started a bit later. Okay, so this is then the forecasting evaluation. So in black and red, we have the number 1 and number 2. And so I'm quickly going to rather go to the next slide to say what happens. So the 1 quarter ahead forecast, the Markov switching models always outperform for France, Netherlands, and the UK. But for the US and Germany, the normal linear models are okay. For 4 quarter ahead forecast, the Markov switching models outperform for the Netherlands and US, and the linear models for France, Germany, and the UK. And for 8 to 12 quarters ahead, the Markov switching models are all so better for Germany, UK, and US. But notice where it's not the best, it's always a close second best. So in total, by taking account for cyclicality, we find that we can outperform most of the time the linear models. Okay. And that's basically the story.
Unfortunately, I will have to continue.
Yeah.
Questions and many questions. Okay. Yes. Maybe I have one question. So you evaluated the actual percentage error, right?
Yes.
Yeah,
it's still on the log data, so obviously that's why it seems quite low. So it's the log differences. So yeah, to take. Yes, yeah, it's still work in progress, like most work presented at the conference. But so yeah, we would like to extend it a bit. And one thing we would also like to include is the contemporaneous business cycle as well. So so that we have excluded at this stage. We've just used the lags every time. But so that is things that need to be done on the to-do list.
Many thanks.
Thank you.
We have Salona for her presentation.
Yes, I hope that it will work. Yes, yes, but it's not there yet.
It's not there. Let's see.
Yes. Yes. Unbelievable. Thank you. Unbelievable. It works from the first. Good morning. Thank you for being here. I will present this paper, which is a follow-up of the paper we presented in 2014 about substitution effect in hotel destination channels. This is a work that I am doing with my dear friend, Roland Scheg of the University of Applied Science of Western Switzerland. Well, you know, we were very concerned about OTA, online travel agency. Probably you have used one of those for coming here, like Booking, Expedia, and so on. And they really trying to boost their business. And this was the CEO who said that our goal is to place internet on where travelers can find the right place to stay, whether the budget it is, whether they need, no matter where they come, no matter where they go. Therefore, these things that seems to be a good wish really has have a disruption in their business model. The first thing is that they decided to include also self-catering accommodation, like a house, secondary house, that people allowed to rent for the short period. Then they have changed their business model from business to customer, and they add peer-to-peer. And the second is they change the nature of in the terms of accommodation, the nature of the product, because now it is not only professional accommodation leading by hotels, but also self-catering. Then this follows a number of acquisition by Expedia and Booking, where they try to cover any kind of service from transportation. And you can see Expedia bought HomeAway, and this is probably been very suggested by the irruption of Airbnb, where the first website was recorded on the 4th February 2009. People want to look of the evolution of Airbnb in Switzerland, there is a paper written by me in the new Encyclopedia of Tourism, leading by Dimitrios Bouchalis. Well, then this is the agenda. I leave you discover the agenda, and of course, internet has really make a disruption in distribution. OTA, online travel agent, begin to play a major role because they are there 24 hours, 375 days. The hotel has underestimated the importance of OTAs, and but they have they spend a lot of money in marketing, and they have an aggressive conversion technique. When you want to book a room and they say there is only one room left in this hotel at this price and you have to hurry up. Well, this is This is marketing techniques. And given that they have not explored, they have not used their own website. And in the end of my talk, I tried to show that they were wrong. Let me show you some things thought about ICT. The ICT does not reduce the number of intermediaries. When internet comes, they say it's wonderful because the hotel has a direct access to the client. And then given the evolution of internet with Web 2.1 and the first, there was a kind of intermediation. And this was very important. And this built a network of interdependence. Well, the aim of the study is to try to see how the substitution effect can be applied to these different channels, generation of channels. Let me make another very quick recall about generation of diffusion models. Well, they have been applied a lot. The main works are by Nigel here and Islam when they work about the generation of mobile phones and more. And then, for instance, the cash system payment. What they are very appealing for us when we were working is because diffusion effect can help us to show the rationality of behavior, saying which is the amount of innovation, which is an amount of imitation, and then we can have a dynamic idea how far or how speedy is the substitution effect. But then there is a very important law, which is a theoretical law proposed by Norton and Bass, which is the law of capture. Which they say that the new generation will totally substituted the earlier one and the old will go to zero. The process will repeat for all successive generation. The demand of the early generation will go down immediately when the new generation comes, and the patterns are the same during the whole process. Well, we use two models, but I have to tell one word about that. We were really pressured by Hôtellerie Suisse, who wants to have an idea how difficult would be the business if OTA wants to have more and more dominance of the market. Then we try to make this forecast. The first one we use, one of the models is Fish and Pri, which is very, very easy. It's an open formula in order to represent S shapes, and there are two parameters which are important: T alpha, which is the half rate of growth, and T0. It means when all generation will have exactly the same share. And then we have a Norton Bass model, which is an extension of Bass model that help us to calculate the ceiling. And then the parameters P of innovation and Q of imitation. There are two models of Norton of Bass. One is that these two parameters are the same across generation, and the one that has changed. We have used the restricted one, and we make the strong assumption that these parameters are the same across generation. Well, let me talk about the data. The data were begin to be gathered by my colleague Roland Scheck in 2002, when we begin to work as a professor in the École Hôtelière de Lausanne, and he's keeping doing that till now. This is the way we pick up the data is a questionnaire that we send to the members of Hôtellerie Suisse, and we ask the share of different channels, which is the percentage of your booking that you make by telephone, by fax, and so on. This is the data. Well, in order to talk about a little bit about COVID, This is the importance of direct data and indirect data. What are direct data? Direct data, it means go in, you call, you send the fax, you send an email. This is our direct. You have the hotelier who's talking with the customer, and then you have indirect. They are all indirect. You can make a book in your Turismo's office of the region, or GDS, Global Distribution System, or OTAs. Booking and so forth. And as you can see here, during the years of COVID, people really try to work on directly and with no intermediaries. And well, then which are the generation? Well, the generation are fixed by the evolution of internet, of the techniques of internet. Then first generation are traditional channels before internet, which also have GDS. Then they are generation 2 when we have online. This means email, reservation in the property website, real-time booking. And then third generation is new line intermediaries like online travel agency and social media channels. Remember, this is very important, that the share are given by the hotel. This is the data that we have. There was 3 years where we were not able to make the survey, but this is more easy is to see the data. This is the data I presented here in 2014, and I just add the new observation. You know, here you have 2012. This was the last observation that we have, and then you have the forecast that I presented there. 5 minutes. Well, as you can see, there is the data of first generation are on the forecast. Well, let me show you. This is the paper I presented in 2014. This is the calculus I have done here up to 2021. As you can see here, the rate of growth for G2 is not significant. And you know, in 2014, I can say that my model was okay. I have very respectable R square and nothing is significant in the Gulf. But here I have some problems. And let me show you the parameters. As you can see, in 2014, the rate of growth was 3 times bigger for G1 and G3, and in G2 I calculated, but they are not significant. As you can see, the parameter of growth is not significant. Let me show you the graph. As you can see, the graph, the first generation decay not so quickly as was forecasting in 2014. And then, as you can see, not surprisingly, generation 2, which is internet direct channel, are just flat, which is could explain that the R square was negative, saying that a naive model could be better than any others. And you can see here, generation 3 is flat. Since 2015, they go around 26%. Well, we can see that the load of capture are violated in the one generation does not put the other in 0, especially for G2, who is constant. And then here we have the parameters are changing because as I go further in my observation, alpha is different. Well, I will skip the part of Norton and Bass, but I can only point it out that using this model and putting out the second generation, we can see that the final penetration for 1 and 3 generation will be around 60%. Then, what is the verification of the observation that we present in the last paper? Well, the first is that there is a ceiling for OTAs around deserve 30%. And G2s seems not to be don't show any substitution effect affected by the other. Well, and there is a violation of the capture law, because for the moment, the product is no longer the same. Now they are not hotel room. Now you have also catering. This is one. And the second, the business model have changed. It is no longer B2C, but peer-to-peer also. And why there is this, why there was not the domination of G3? Well, and with this I finish, I have two different hypotheses. The first hypothesis was that the hotel has built a defensive strategy. Instead of give the rooms in the OTAs, people call to the hotel or send an email and they make some discount. Then if it is like this, the fact that OTA has no growth, this not harm hotels. I have a second hypothesis that it could not be opposite or exclude from the first one. The second hypothesis is that the fact that now OTAs offer also self-caterings, probably people, there is a leakage of the people that they will not choose hotels anymore and go to self-caterings. And this is on the whole level. It has been done the 5-star hotel where people say, I pay a little bit more, but I have the chalet of my life, or people who say, I will have a room, share room in a house. Then this is a very important fact, because if it is the case, the fee that OTAs, Booking and Expedia ask to hotel should be lower, because now they are building a direct competence to their business. And remember that the data that I have come from the hotels. It means that it doesn't mean that OTA are losing money. They are selling less hotels rooms, that's all. But this is an open question. Well, thank you very much. And I can remember that I remember someone who says forecasters spend half of their time making forecasts and the other half explaining why they were wrong. This is my case. Thank you.
Like how the comparison between what we were expecting back in 2012, that the decline of the generation one was way fast, and generation three, like the increase would be much higher, and that it was quite different than now.
Yes.
That was really interesting. Like one question from us, and when you collected the data from Swiss hoteliers, you said, do you think this is also something which could be observed in other European countries?
Yes, my colleague Roland Scheck is beginning to make a big, since 5 years ago, he's replying this survey in all Europe. We are making the survey in 37 different languages, using Sphinx software, French software. Yes, and all the data are built with the SAS. All the analyses are made with SAS. And what I would like to add is that last week there was in the newspaper in NZZ, the CEO of Booking, who was talking that this survey was not really made in the random way, and probably our figures were wrong. And of course, because the law has passed, the parliament, the Swiss parliament, has override the obligation of hotelier to offer the lowest price in Booking. This is the problem. The parliament has override, and we have to work for the parliament making the reports and so on. And then we publish, Roland Scheck published a press release where we explain that this data is a panel. The data are proportionally represented cities, mountain and lakes. And even though probably the absolute level of penetration given was not that, he cannot deny the speed of growth. Yes, it was a nice work. Thank you, thank you.
Come return customers. Stay here with it once and then return. Yes. Return customers. Stay there once and then return and then I contact them. Because that's fine. They know that at what moment of the year, in April, they will receive this program, and I think that they are almost there is the curve of the year that they are always because they see how important for them. Because when we go to the parliament, we make several studies. I think that study showing that the increase of the price of water below the level of ICT. And then the people, yes, answer because they know that it's good for their sector.
Many thanks. Any other questions we have at this moment, or after the session that we make again? And now the third representative of Singapore, am I pronouncing it correctly? Yes.
Thank you, Korsin Kapul. But the other one works also. Thank you. Yeah, well, thanks for having me here today. I'm from University of Applied Science of the Grisons, and I work there as Director of Studies, Computation and Data Science, where we have a great bachelor program. Well, tourism plays a really important role in Switzerland, and especially in Canton Grison. On the photo, you see the UNESCO World Heritage Tectonic Arena Sardona in the tourism destination Flims Lacs Valera. And there the research project happens. Well, in this region, we have about 8,500 properties and just 77 days of owner occupancy per property. And this ends up in just 18 days renting per year. And there you see the great potential for renting these properties to other persons. Well, just to think about it, University of Applied Science of the Grisons is on the eastern part of Switzerland, the region where also the World Economic Forum takes place. So there's a rise of alternative accommodations such as rental holiday homes. We see this also by the talk before with Airbnb and other booking platforms. Well, nobody wants to spend time to manage this accommodation because there are things to do like cleaning these accommodations, like reception desk, like other things you have to spend time with. And because most people don't want to do this, there's a need for a company which serves services. Very important thing here, accommodations that are not cleaned cannot be rented out. And that's the limitation. And often in this region, arrivals and departures are concentrated on one weekday. So every Saturday morning, all guests are leaving. And there's just a short time window, often between 9 and 3 p.m. to clean this accommodation. And the number of cleaning staff in these tourism destinations is very limited. Yeah, there are small villages with not a lot of people who want to clean these accommodations. And therefore, planning of human resources is a major challenge for this accommodation renting. We did a research project called Staff Allocation and Scheduling for Property Management in Tourism. There are two parts on this research project. First of all, we did the staff allocation problem, and after this, the staff scheduling problem. It was a mixed method approach with our tourism department, the Institute for Tourism and Leisure, and our Institute for Photonics and Robotics. There are two partners involved, the White Arena Group and also the company which manages all this accommodation, the Lacs Homes. This Swiss innovation agency funded the project with about 700,000 Swiss francs. The interdisciplinary project team is made up of myself as project lead and about 8 researchers and research assistants from the field of tourism and also data science. So the project consists of the following parts. Which holiday property should be cleaned in which order by which project team? For this, we developed a constraint solver, a research prototype, because it's very important in which order you clean this accommodation with which cleaning staff or cleaning staff team. Accommodations are spread over different locations, Flims, Lax, Ferreira, and other destinations. And there are also different cleaning times for different accommodations. It depends on the number of rooms and other things. There are different availabilities of cleaning staff teams and frequently short-term bookings, especially in the Corona or post-Corona time. And staff allocation is always very time-consuming for the company Lax Homes. And there was the second part of the research project, and the third part. Our tourism department does the research things on the touristic side, and this was very important for us to find the right regressors for our model for the forecast afterwards. Yeah, building on the findings and the domain knowledge from tourism research, we developed a research prototype to forecast the number of departure 28 days before. And that's the thing I will talk today. We followed Hindman's 5-step approach within this. We did lots of explorative data analysis. We did lots of experiments. We tested this with root mean squared error. We did grid search, hyperparameter tunings, all the things which you should do in general. So that's the system architecture of our research prototype. We provided all this as Docker container, and this could be used by the company Lax Homes. So on the right side, you see the staff assignment planning and time recording tool or software, Eurotime, the standard software which they used. And from there, they initiated the forecast. Yeah, we did a data extraction and pre-processing here. We need tourism season data, we need holiday data, and some other data for the forecast, and did the departure forecast. And this all was integrated in the system architecture by this company. Yeah, how looked the time series data? Time series data consisted of daily data from January 18 to March 21. It's not a lot of data, but the company Lax Homes was built, I think, on 2017 or 18. Then the date is multivariate. This means involves 2 or more variable quantities, departures, apartments, and this also counts data. They are strictly positive integers. And as we can see here, the data has multiple seasonalities. So the winter season, the summer season, and so on. Here we see some data from January 19. We have in total 58 apartments. The departures are primary on weekend. Yeah, Saturday, you see this on the 26th of January or the 2nd of February, maybe. And on the other side, we see here the data from January 21. Yeah, number of available apartments nearly double from 58 to 112. And the number of known departures multiple weeks in advance decreased rapidly. So what's going on? That's the COVID time. All data is less useful. So the departure day is not that strict as 2 years before. So this changed, in this project. The data set has just about 1,000 entries, and this means some machine learning and also deep learning approaches seems not be suitable. Strict properties of the data to be always integer positive and greater or equal 0 will count data. Models like ARIMA, SARIMAX appearing less suitable because they return positive and negative floating points. And Poisson, negative binomial, and generalized regression methods are more promising. Well, we have time series data with multiple seasonal patterns. I think Prophet or TBATS are more suitable than other methods. Yeah, well, we tried several regressors to forecast the departures. On the left side, we see the used regressors in the final model. The total number of apartments in the portfolio, very important, increased from 58 to 112. The number of known departures, 4, 6, 8, 10, and 12 weeks in advance. The percentage of reservations of the total number of possible reservations. Also, some weeks in advance. The weekday, because most of the departures are on Saturday, maybe Sunday. The holidays from Switzerland and UK, and the season of tourism destination. And all this we did with our tourism research results. We tried also other regressors that were tested, but not included in the final model. Well, COVID-related decrease, which affect the hospitality sector. We tried peak season and off season of the tourism region. We tried holidays in Germany and Poland, because our tourism department says, yeah, there was an increase in, I think, February 2020 with Polish guests. We tried some weather, temperature, snowfall, average wind speed, and things like this, but this works not as expected. And we also tried to include in our final model events in the tourism region, yeah, maybe Lux Open or Schnulz im Sulz or other events like this, because lots of people go to this region for these events. That are our results. We got best results in our tests with the profit model. This was also the model which we provide on the customer side. The Poisson models work well as expected. Yeah. This is what we see, or what we saw in the travel behavior change this COVID time. 5 minutes, great. Well, the structure of the data changed massively during the project. This table shows absolute number of departures during each season and the known departures 4 weeks before. Noteworthy here, we have a positive trend in departures and bookings. We have a number of guests making their reservations 4 weeks or more in advance decline rapidly in the summer season 2020. Well, we don't know if it's because COVID, but yeah, maybe it could be because COVID. And then we also have a peak in summer season 20. This was the first summer of the pandemic, travel restrictions. It's very interesting to see this also in the data. To conclude, yeah, with this forecast, our Lux Homes company could better meet long-term planning for management, staff, scheduling, and allocation, because we forecast the number of departures and they could plan this cleaning staff. Then we see the short-term change in travel behavior could be taken into account. We trained several models, one which takes the normal parameter, and the second one which put more emphasis on newer data, which was very important for the COVID time. Then, yeah, I think the travel behavior must be monitored, because this changes in the next years, or maybe goes back to an old behavior. Yeah, well, how will travel behavior change in the long term? We don't know. Maybe what's about the pre-booking period? Yeah, influence of digitalization on booking behavior. As we see all these platforms like Booking.com, Airbnb, yeah, I think this will change the travel behavior definitely. And also, can the findings be generalized for other tourism destinations? Yeah, this is also an open question. This from my side. Yeah, maybe there's some questions.
Great, very succinct presentation. So that is what I like. Some time for questions now.
Yeah.
Where we try to analyze the window to booking, and we have different physical data. But we can, the best thing to do is make to separate the origins. Then but what we have done always is to transform this weather data in categorical data following the icons of Swiss, because you see the weather is very subjective. It means that people in Sweden as a resistance to how you say, to cold more than the Brazilian. And then if you take care of the icons, it's a suggestive way in order to say, well, they look to the same thing. And it's very, I can't see to the paper where we use that, but very interesting.
Yeah, thanks for the paper. This would be helpful. Well, the weather data, we tried several things with the weather data. In general, we think that the weather is important for the short-term bookings and also for the daily guests, but not for the bookings 2 weeks before. Yeah, so because that's another time period. And most of the bookings, I think, are more than 7 or 10 days before. Yeah. Yeah, maybe we try this. I think that there's another paper from this region for ski day forecasting, and there the weather has a really great impact because, yeah, you decide tomorrow I'll go skiing, and you look on the weather and on the ticket price also. Yeah. Thank you. Great.
Like, has this first question is easy? Has this project already been concluded? So has like the donor have they been like happy with what you could present them?
Yeah, we did. They work also with these artifacts from the project. So for the SCAF scheduling and allocation, and they use both. Yeah. There's also paper from the first part of the project.
That's perfect if you can really provide and develop something that then is also used.
Yeah, well, the more difficult part was the culture part, how to integrate this in this company. Yeah, so it helps, and yeah, it doesn't cost some working people or something like this.
And a second question, like just a small detail, since you were using the THS routine, as far as I remember, I think you can either let like the routine select how many different seasons there are, or you can also tell it that okay, there's like an annual season, a weekly season, or something. Do you remember how you proceeded with that?
Yeah, well, we tried several parameters.
Okay,
yeah.
Okay, and then
for all of these models. Okay. Yeah, we have a grid search for all the parameters we tried with all the models.
Perfect. Many thanks. And
great, thank you.
Another question in the audience.
Just going about the German holidays, significant holidays you use because several states have different holidays in several reasons.
Yeah, I think we concluded all the holidays in Switzerland to one holiday data set. We use also UK holidays, but not the holidays from Germany itself. Yeah. Yeah, I think in Germany, we just tried some regions out of this because we know which guests were on Lux, and we could yeah, just do it with this guests from this region. So, but it was very individual, and it needs a lot of domain knowledge, tourism domain knowledge. That's very important in this research project. Yeah.
Okay, many thanks for remaining questions. Please during the coffee break, because we have to move to Manuel Silva for the last presentation of today's session. Many thanks again.
Thank you.
to present here?
Yeah.
All right, hi, good morning, everyone. Thanks a lot for joining this presentation. So my name is Emmanuel Silva. I'm from London College of Fashion, which is part of University of the Arts, London. And as the title says, I'm trying to see what kind of relationship exists between the tourism and fashion industries through my work. So what will I do today? I'll take you through a bit of the background, the rationale as to why we thought of doing this study, the methodology, the data we use, the findings, and potential explanations for the results that we did find, and obviously the conclusions and a list of references for you. So in terms of the background, this all started way back in 1885 when Thomas Cook organized the first pleasure excursion, which included a guide to recommended shops abroad. And since then, fashion and tourism, shopping and tourism both have gone a very long way or come a very long way. But then obviously shopping is considered as one of the earliest and most popular and most important aspects of tourism. And this then brought this concept called tourism shopping to the forefront. And tourism shopping is defined as the expenditure on goods purchased in a country by international visitors, either for consumption in the place where it is bought or for export, but not including expenditure on food, drink, or grocery items. And through the literature review, what we noticed was that most of the tourism studies that deal with retailing and shopping have been associated with behaviors, motivations, authenticity, purchase intent, and so on. But we didn't find any attempt to try and see whether we can use the relationship between the tourism and fashion industries to improve the accuracy of forecasting in that context. But what we do know is, based on previous research, there's evidence that says that tourism has a positive impact on retail, with 1/3 or half of a tourist's total expenditure being spent on shopping. And through this study, we are focusing on one particular country, which is the UK. And the reason for that is that before the pandemic, UK was one of the top 10 tourist destinations in the world, with 38 million visitors. And obviously the government was launching this new initiative called the Tourism Sector Deal, which was aimed at uplifting the tourism sector further. The pandemic happened, this slowed things down, but recovery is expected by this summer. So they're expecting tourist arrivals will go back up to at least 24 million by the end of this year. And that spending would rise to 19.2 billion again. And as a result, a series of actions have been outlined by the government again to try and promote tourism. So with this background, we thought it was interesting to try and see whether we can contribute in some form to helping improve the accuracy of forecasts. So the question that we are trying to answer is basically, can fashion retail sales in the UK be a leading indicator for tourism demand into the country? What's the leading indicator? It can be defined as the fact that future changes in some aggregate economic activity is often overshadowed by some other changes in some other time series variable. And these other time series variables can be defined as what's called leading indicators. What you need to notice that here, due to data limitations, we do have to use proxies. And so we rely on the volume of non-seasonally adjusted total retail sales from textile, clothing, and footwear stores as a proxy for fashion retail sales, and also as a variable which captures the effects of tourism shopping. But yes, it's not perfect because this data includes both tourism shopping and the local expenditure as well, but we had to work with this for the time being. Why did we want to do this research? So shopping is known to play an important role in tourism demand, also known for increasing tourist arrivals into a country. To the best of our knowledge, this is the first time we are trying to exploit the relationship from a forecasting perspective and try to empirically evidence what can be done from a forecasting perspective. And the real reason to do this was currently the fashion industry is struggling post-pandemic, post-Brexit. There is a problem, the high street is failing. So is there scope to show that more cooperation between the fashion and tourism industries could help both industries to revive post-pandemic, post-Brexit, and as a result, help overcome some of the social and economic problems that would arise if there is continued unemployment due to shops having to close and so on and so forth. And the research has shown that even though fashion events do add value to tourism, that it's not really recognized that much by the stakeholders. So again, can we use this research to motivate the stakeholders, the policymakers, to really see that there is value? So we need to give some attention when we are formulating policies to what and how the fashion industry can impact tourism arrivals into the UK and so on. In terms of a methodology, we rely on a technique called multivariate singular spectrum analysis. In very brief terms, it's the univariate singular spectrum analysis applied to multiple time series. People who are not familiar with it, basically what we are trying to do is we take noisy time series, right? And then we try to decompose it into signal and then differentiate the noise. And then we try to leave that noise component out and reconstruct a less noisy time series. So that the idea is, if the randomness of a time series is reduced, hopefully the model should fit better. And as a result, the forecast should be better in theoretical, in theory at least. The model itself includes 2 stages, decomposition and reconstruction, each with its 2 steps called embedding and singular value decomposition. And within the reconstruction phase, that's where you group the signal and noise separately. And then you use diagonal averaging to create a new time series, which is a reconstructed version of the original series that was input into the system. We consider several benchmarks. All models were estimated using the forecast package in R, except for SSA, which was done with our own algorithms in R. 5 different models were used as benchmarks: the seasonal naive, auto ARIMA, so the seasonal ARIMA, exponential smoothing, neural network auto regression, and TBATS. The exercise used 2/3 of the data for model training, 1/3 was left aside for testing. For the multivariate models, we evaluated the relationships as different lags, so lag 0, 3, lag 3, 6, and 12 months. And what we report are the best outcomes only. The accuracy of forecasts were distinguished using 2 loss functions in particular, the root mean squared error and the mean absolute percentage error. And also the ratio of the root mean squared error was used to quantify the gain made by one particular forecasting technique over another. The data came from the Office for National Statistics. The retail sales index provided the fashion data. They also have the tourism data accessible freely within the platform, so we use that data. This is what the data looks like. Extremely seasonal as expected. Fashion is seasonal, tourism is seasonal. And the data spans from January 2004 to October 2019. So yes, it's pre-pandemic. And that's one of the limitations which we talk about in the paper at the end. But what we are trying to do here is try to motivate and show that when a correction occurs, does the relationship hold so that it's worthy of cooperation between the 2 industries. Check the correlation as expected, very low correlation, but for singular spectrum analysis, modeling, it's the co-integration between time series that matter rather than the correlation. So we went ahead with trying to model this data further. In terms of some quick descriptive statistics, we found that the fashion retail sales were more volatile than tourism demand during this period. This was monthly data. Median fashion retail sales were at or above 3.3 million per month during this period, and median tourist arrivals were at or above 2.7 million during this period. The seasonal plots showed us that fashion retail sales were peaking in December annually, whilst tourism demand was peaking in either July or August, to do with the weather we see in this country during this time period. And each year we noticed that as the time approached towards February, fashion retail sales and tourism were actually dropping significantly. And this is to do with the onset of the Chinese New Year and the importance of the Chinese tourists within the UK economy, because we find so many Chinese tourists flying in to buy luxury on the high street and then just come in for that purpose, buy the items, fly back out. So there's a lot of spending going on. There's a lot of arrivals happening as a result, and we can see that impact on the data as well. What are we trying to do the modeling? In terms of the univariate scenarios, if you are trying to forecast tourist arrivals for the UK using univariate models, at H equals 1 month ahead, we evaluated at 1 month ahead, 3 months ahead, 6 and 12 months ahead. We found that TBATS was best in the very short run, ARIMA for 3 months ahead forecasting. But for long-term forecasting, it appeared that from a univariate perspective, seasonal naive was outperforming all the other univariate models. So you didn't necessarily need a complicated time series model to predict UK tourist arrivals in the long run as per the findings we have here. We then applied the multivariate models, which was a combination of fashion retail sales and UK tourist arrivals. And these reported the lowest out of sample forecasting errors, which are shown in the last two columns. So there are two versions of multivariate single spectrum analysis. One is called the recurrent forecasting algorithm, and the other is called the vector forecasting algorithm. And that's why you see two columns there. And based on the RMSE and the lowest RMSE, yes, there seems to be some evidence that fashion retail sales could be a leading indicator, but of course, these results could be chance occurrences. So we went a step further, calculated the ratio of the root mean squared errors, and then tested the forecast errors for statistically significant differences using the modified Diebold-Mariano test, and also the Kolmogorov-Smirnov predictive accuracy test, which I developed during my PhD with my supervisor, Hossein Hassani, who's also a co-author in this paper. So how do you interpret the ratio of the root mean squared error? If you take the first example, it says 0.69. That means the multivariate model is outperforming the univariate model by 31% if you want to quantify the gain that is made. What we found was that there were a high number of statistically significant outcomes when we compare the multivariate forecasts with the univariate outcomes. In fact, 80% of outcomes were statistically significant in terms of the differences. Went a step further, tested it using Granger causality, and we found evidence of a causal relationship flowing from retail sales to tourist arrivals. We also compared the results again with the univariate single spectrum analysis as well, just to make sure that it wasn't the model that was giving these results, but the inclusion of fashion retail sales as a predictor in the model. We also did, even though I don't report it here, we also did test the data without the holidays to see whether the relationship still holds. So we removed the holiday effects in the model. And what are the potential explanations? So shopping is known to be a key pull factor to attract tourists to some city destinations. We don't think this relationship will hold across the board, but we think for countries like the UK, even for maybe Paris, France, we might find similar relationships that could be exploited. And tourism is one of the most successful industries for the UK, and tourists are motivated by their desire and necessity to shop. Tourists visit the UK specifically to benefit from the latest fashion trends. And statistics a bit outdated, but this is what was available, show that 57% of all visits to the UK involved shopping in 2014, and 40.7% of inbound tourists shop for clothes or shoes during their visit. London was also ranked as the 4th most important fashion capital in the world, and it houses some iconic department stores, which again motivates a lot of tourists to come in to experience, explore these venues. And yeah, 16 million tourists. So in 2018, there were 34 million tourists before the pandemic. And the data shows that approximately 16 million come from outside the UK specifically to shop in this country. So you can see there is a huge impact of tourist arrivals and the correlation with the interest in shopping. And during the pandemic, luxury brands actually suffered as a result of a drop in tourism because their revenues took a huge hit as reported. So thus we conclude that it's likely that tourism shopping makes a significant contribution to UK fashion retail sales and can be one potential explanation. And I use the term one because this data captures both local and tourist shopping in the present context. But yeah, so we cater to this work, to try to cater to this work by introducing a new leading indicator for tourism demand forecasting and adding to the existing set of indicators ranging from economic data and so on to that list. The real aim is to try and foster more cooperation between the fashion and tourism industries. And yeah, go back to the start, back to 1885. Perhaps, we need to create more specialist travel packages tied to fashion events because recent research has shown that fashion events not only augment the image and personality of cities, but also create a sense of loyalty. So people actually keep coming back if you can create that experience for them in practice. Several limitations in this study, which we outlined in detail in the paper, and several research avenues from a data perspective, from a methodological perspective, and even from a consumer psychology perspective as to what can be done to bring tourists back after the pandemic and to revive the high street and benefit tourism as well. And yeah, this paper was just published in July this month, start of the month, because it's been under review since I submitted. So you're welcome to read it if you have an interest in the work. But thank you very much. That ends my presentation.
Yes, let's start with the questions here, then I also.
Sure.
Thank you for as a new and perspective towards forecasting literature. My question is actually demand for retail sales. First, actually the causal relationship here to me institutionally is from tourism, right? So I would think tourism is a leading indicator of retail shopping. But somehow your study suggests that retail sales a leading indicator of tourism. So that's a little bit connections to what normally people think.
Yeah, so actually we did test that relationship as well. So we tested both relationships, and we couldn't find any significant outcomes when we tested it the other way around. But when we put fashion retail sales as the indicator, then the results were actually improving the forecasting accuracy. But otherwise, we could not find from the other perspective when we did for this work. But again, maybe if we try different methods, I wonder if we can figure out a relationship. But here we did not find that in this particular context.
Thank you very much.
Yeah.
And the home directions. The comparisons. Your the method. You only use the universe tourism and where is the mount and
Yes.
with the connection of the level.
That's right.
And with the neural network, did you try again? I think kind of causal relationship as well, relationship between fashion and tourism, or was just univariate?
It was just univariate. Yeah, all the forecast package models we use here were univariate.
At one point, you only show the top shops in London. But why not? Because there are a lot of tourism. You didn't show that.
Of course.
If you go to France,
Everyone's
especially the
yeah, I think the problem is as a college and school, they have this view that Primark is not sustainable. So they try to, keep that out of the conversation, but you're quite right. Yeah, there's a whole discussion on sustainability, affordability, and yeah, people do fashion the Primark and it's affordable.
you're very good as well, right?
Yes, it was included, definitely.
Okay, very good.
Yes, thank you for the have you taken into account the sales day? When they are the seasonal sales day, because I don't know how it's in UK, but in France it's really important. There are people going to Paris, just running into the Galerie Lafayette when they open, and it's. So have you taken into account that?
We took it around the holiday events, but not particularly the Black Friday sales or the Christmas. So we just took it around the holiday events in this particular relationship. So that might be something interesting to look at.
Yes, the intervention program. And I have a second question. When you talk about fashion, do you take also luxury things like watches? Because if you do that in Lucerne, you will have all the time people, the Chinese go to Lucerne to see the bloody bridge, but to buy the watch. How could you use this method?
Of course, yeah. I think that's why I said it is a proxy for fashion, because as you say quite rightly, fashion can include jewelry, accessories, but here the data at the Official National Statistics only reports textile clothing and footwear, sales from textile clothing and footwear. So I was limited by that, but you're quite right. Well,
So we have one, let's say, one more point is the discussion that,
So could you say something about the lead time maybe? And so, and what's the intuition behind this? And so people are coming to shop, right? Shop. So this happens at the same time. And so how can one individual be leading this? And we have any intuition behind this? And can we measure the lead time?
yeah, I think so. Some of the results were actually at a 6 or 12 month lag. The indicator was leading at a 6 or 12 month lag. And so that's where we think things like loyalty come into play. Because when people come in and experience something, they come back, and the second time they potentially come back with more friends and family based on the experience and social they have. So we
One
think
thing
that
about this, you might try wavelets, because wavelets, if you have a cross community wavelets, you can measure it by a fraction of one. If you make that, that might differ a lot. Under the range of that's possible.
thank you very much.
and yeah, thanks a lot. I think to all presenters.
Thank you very much.